Namaste. Greetings to all reviewers. My name is Pooja Todke, a PhD research scholar from Institute of Chemical Technology, Mumbai, presenting research entitled as Amphotericin B Nanoformulation Insta-AmB Tracking Safer Monomeric AmB Release. As we all know, amphotericin B is a gold standard for the visceral leishmaniasis, and the first conventional AMB therapy exists in aggregated AMB, and which is non-specifically interact with the human cholesterol. This results in a liver and fetal kidney toxicity. To overcome the toxicity issue, lipidic AMB nanotherapy came into picture, which exists in superaggregated AMB, which is also called as a monomeric depot because it releases the monomeric AMB and which is specifically interact with the fungal ergosterol, which significantly decrease the toxicity. Nevertheless, there are many challenges are associated with lipidic AMB nanotherapy. Therefore, we present Insta-AmB, a safer amphotericin B nanotherapy prepared by Facile Technology. Insta-AmB development was initiated with the screening of lipids using molecular operating environment software. For a molecular docking study, we were selected various fatty acids containing excipients from a shorter to longer. As you see on the left side, the shorter fatty acid containing excipients reveal an incomplete wrapping, proposes the aggregated AMB. While on the other hand, longer fatty acid containing excipients reveal a complete wrapping, which proposes the superaggregated AMB. Further, we are demonstrating interaction of Insta-AmB with the cholesterol and ergosterol using molecular dynamic simulation. Insta-AmB lipid complex, and we have used control as a liposomal AmB and aggregated AmB, which are simulated with the cholesterol and ergosterol respectively. And the result demonstrated that Insta-AmB lipid complex does not interact with the cholesterol, which is comparable with the liposomal AmB, and a significant interaction was observed with the ergosterol. However, in the case of aggregated AmB, reveal a significant interaction with the cholesterol, and with the ergosterol revealed a limited interaction. After selection of novel lipid, Insta-AmB were prepared by using an in situ nanotechnology. Insta-AmB is an example of technological breakthrough. Insta-AmB is a pre-concentrate. It is a simple solution of AmB plus excipients in a pharmaceutical acceptable solvent. At the patient side, while administration, Insta-AmB is withdrawn using a syringe and is simply added into the dextrose injection, which results in the instantaneously generation of AmB-loaded lipidic nanoparticles. Now, Insta-AmB is ready to inject. More than 95% is AmB in trap. TAM revealed size about 80 nanometer and PDI 0.340. And importantly, Insta-AmB revealed super aggregated state of AmB. The objective of the present research, a very novel application of dissolution testing in a tracking safer monomeric release from Insta-AmB by using UV spectroscopy. And the principle behind is, as you see, UV spectrum showed the peak 1 between 321 to 325 for the super aggregated AmB, peak 2 between 330 to 350 nanometer for aggregated AmB, and a third peak between 405 to 450 nanometer for the monomeric AmB. For in vitro release of Insta-AmB, we have used two dissolution apparatus, USP2 and USP4. These are the conditions followed for the dissolution study. We perform dissolution in a 2 biorelevant media. Since it is an intravenous nanoformulation, we have used simulated intravenous parental medium, that is Krebs-Ringer buffer pH 7.4 with the 4% albumin. And second medium, since Insta-AmB is targeted to the intracellular infectious diseases like a visceral leishmaniasis, for that we have used simulated intracellular lysosomal biorelevant medium, that is artificial lysosomal pH 4.5 with a 0.2% Win 20. And liposomal AmB nanoformulation was used as a reference. Coming to the major objective of the research, that is tracking of monomeric release. In the USP2, a low release was observed in the KRF and very high standard deviation was observed in the KRB as well as in the ALF. In the ALF media, a rapid release was observed and which is important for the intracellular infection like a leishmaniasis. Coming to the tracking by the UV spectroscopy at the initial time points, that is 10 minutes, Insta-AmB and liposomal AmB revealed a super aggregated AmB peak. Then over a period of time at a 6 hour in a dissolution media showed a decrease in the super aggregated peak with increasing the monomeric peak. Tracking of monomeric release in USB4 apparatus compared to the USB2 showed the complete release was observed in a KRB as well as in an ALF, and also low standard deviation was observed. Similarly, USB2 in a USB4, the faster release was observed in the ALF as compared to the KRB, which confirmed the augmented intracellular drug release. FT value more than 50 indicated that Insta-AmB, which is comparable release profile with the marketed liposomal AmB. Likewise, tracking of USB2 release, USB4 revealed a super aggregated peak in the Insta-AmB and liposomal AmB at initial time points in a dissolution media. Over a period of time, in both biorelated media revealed an increase in the monomeric peak, which confirmed that super aggregated AmB would serve as a monomeric depot. Overcome the toxicity of amphotericin B is a biggest challenge, and importantly, as a demonstrated safer monomeric release, further safety evaluation of Insta-AmB is necessary. For that, we have performed in vivo zebrafish toxicity study. OECD 2.0 guiding protocol we have followed. Danino rerido zebrafish incubated with a different concentration containing the AmB nanoformulation, and the mortality was recorded up to 96 hours. Toxicity results demonstrated that a 10-fold higher LD50 of Insta-AmB compared to the aggregated AmB confirmed the enhanced safety. Similarly, the safety also confirmed by hemolysis study. Insta-AmB show less than 15% hemolysis, which is comparable with the gold standard liposomal formulation. And in the case of aggregated AmB micellar formulation showed at a lower concentration 100% hemolysis. So the low hemolysis propose a safety of Insta-AmB. Coming towards the anti-leishmaniasis efficacy. For that we have used infected microphage cell line with a luciferase transfected Leishmania donavani bromastigotes that converted into the amistigot. Then Insta-AmB and standards were incubated for 72 hours and luminescence was measured. And results demonstrated that that's 11.22-fold lower IC50, 3-fold lower CC50, and thereby 3.66-fold higher selectivity index compared to the standard, which confirmed the superior efficacy coupled with the safety of Insta-AmB. I would like to conclude. We demonstrate in vitro dissolution testing as a practical and a useful tool to predict the AmB nanoformulation safety. Thank you by saying Insta-AmB, ensuring safety through monomeric AmB release. I would like to acknowledge my research supervisor, Professor Padma V. Devarajan, and Mr. Suhas Evle. I'm very thankful to Sodax India Private Limited for USB2 and USB4 apparatus. Thankful to Cipla Private Limited for a gift sample of Amphotericin B. Thank you so much.